I wish I had memorized my talk like the previous speaker. First thing I'd like to do is I'd like to show you what a stack of fuel cells look like. This is one of the working pieces of any fuel cell that you're going to find worldwide. It's got cellophane on it. Six of them go into our home unit. And what I'm doing here is a little furniture rearranging. They brought along the casing that houses our residential system. A fuel cell is a 2-inch disc made of ceramic. They convert fuel into electricity and heat. They use an electrochemical process that is many times cleaner and less polluting than engines and turbines, which are also noisy. This prototype puts out 24 kilowatt hours every day, which is enough to carry the base load of a typical home. Because it's a prototype, it's larger than our final commercial product will be. Inside, we have designed it to be extremely simple, so much so that workforce who know how to make appliances will not have any difficulty assembling these, as well as workforce who have made component parts for the automobile industry. Fuel cells are not new. They were discovered back in 1838 in England. And you may wonder what's taken so long. The challenge is, one, making them able to accept ordinary fuel and not just hydrogen. And second, bringing the cost down, the cost of making the system and the cost of operating them. The Department of Energy alone has spent over $1 billion addressing these issues. This has been such a difficult task that in the world today, there are probably only about a dozen companies that have built a kilowatt fuel cell system or larger, operated on ordinary fuel, and demonstrated the system outside the laboratory. TMI is proud to be in that group. Last Sunday, for those of you who may have seen 60 Minutes, I think the entire industry got a shot of adrenaline as the newest company to join that club of 12 made a spectacular debut. Now the challenge is driving our costs down by making lots of them and making those stacks more robust. Fuel cells are a disruptive technology, which means there is no measurable market demand for them. If you don't know they exist, you're not going to be asking for them. I think Henry Ford's classic comment was, if I had asked my customers what they wanted, they would have said faster horses. Some of the features that are difficult to comprehend because there are no reference points are, number one, this box runs 24 hours a day, 7 days a week. Besides the wall socket in your home, try to think of anything which generates power continuously, 24 hours a day, for years. Solar panels, wind turbines, and diesel generators are intermittent devices and have to, number two, another distinguishing feature is that these can be used indoors. None of the former can be used indoors. They also don't produce carbon monoxide, which allows the heat to be available, to be added to the electricity. Third feature that is not easily referenced is the fact that even at the small scale, these can be as efficient as large power plants. And when you add the heat in, they can be over 90% efficient. There's nothing like them. Small is truly the new big idea. TMI, my company, is a David among some very large Goliaths. We had to differentiate our system by engineering features that produce high value. Some of these features were compactness, which I'm showing you here, and also our ability to run on many, many types of fuels. On the chart, you can see the list of the fuels that we have operated on successfully. The ones in the color green are renewable, of course. You'll notice that they are both gas and liquid and include fossil and renewable. With this type of flexibility, we feel that we can go after an awful lot of niche markets, as it's described. Some of these would fall into residential, where we can run on natural gas from the pipeline that goes into most homes. Auxiliary power units, which would run on kerosene, diesel, propane. Military, which we think would include disaster relief and first responders. And in rural areas, we have made our systems run on raw vegetable oil, like soybean oil and corn oil. And we've also run on non-food oils like jatropha, and even on used cooking oil. We're also looking at commercial applications, near biomass converters. There's a great deal of activity now converting biomass into biofuels. We've run on biodiesel, we've run on ethanol, we've run on simulated digester gas, which comes from rotting cow manure, food processing waste. I mentioned that there are only 12 companies about there that have actually shown demonstrations. These are some of our demonstrations. One in particular at the top left, you can notice we have 3 of them working in parallel. That's how you get more power with fuel cells. Just bunch them up, and you get redundancy as well. The group of people who are smiling is the Ohio Soybean Council Board, who wanted us to run it on soybean oil. And so we dragged it down there to their board meeting, and it's powering a dollhouse on soybean oil. We have also recently run it for 30 days on a farm, unattended, about an hour from our laboratory. This is the kind of field trials that in our business you must go through to make it bulletproof before you bring it to market. And I think our biggest achievement is running it on military jet fuel. One of the pictures shows, it's the little beige box in the lower left-hand corner with the general in the front. This is running at Lockheed Martin, where we are working with them to see how well fuel cells can be used to substitute for diesel generators. What I'd like to do now is to, if I can get this is to shift gears and to move toward the subject of my talk, solving global social problems using fuel cells. We have to shift and also start imagining about what could be in the future. During her 2008 commencement address at Harvard, author J.K. Rowling described imagination as the fount of invention and innovation. In the technology world, innovation means deploying inventions. It's like the fuel cell. It's actually where our entire industry is right now, and it's very exciting. As I imagine in Ohio how this would fit into the subject of my talk, I can see thousands of workers skilled already in making appliances, now applying their talents to manufacture fuel cell systems. I can see our transportation hubs moving in the pieces and parts from manufacturers, and even moving it out as we export to global markets. I can see the waste biomass that we have so much in Ohio, replacing foreign oil as a feedstock, and not only producing biofuels, but bioproducts. I can see a vigorous distribution generation industry. That's where you generate the power where it is needed, where clean, renewable energy is being generated. And I can see students learning about energy not as part of a science class, but as a core curriculum that they will live with for their entire lives. But in addition to all of the business, commercial, and industrial opportunities that we're working on, I can also imagine how fuel cells can change the lives of 4 billion people who now live at the bottom of the economic pyramid. Most do not have electricity, and most live on $300 a year. The World Health Organization has reported that public health is a major issue, but it can be fairly specific. 1/3 of the 4 billion people suffer from diarrhea annually. Of this number, 2 million infant deaths are reported from diarrhea alone. That's 228 infants dying per hour from diarrhea. As we think about this market, we believe there are probably millions, if not tens of millions, of mothers who would want fuel cells if they knew it could increase the quantity and availability of clean drinking water. Just by powering pumps which move water through sand filters, adding the benefits of an ultraviolet light to zap the disease-bearing microbes and pathogens. As we look into the bottom of the pyramid, we see NGOs. You don't have to look very far. We have many, many NGOs. That's the acronym for a non-governmental organization. In this country, it'd be called a 501c3. Tens of thousands of trained workers are at the delivery end of billions of dollars flowing into the developing countries through these NGOs. Most work at the village level, addressing chronic and public health problems. This is a well-known root cause of poverty. But most NGOs don't know about fuel cells. Just think how the Anywhere Energy system, something like this or a group of them, could amplify their productivity by simply providing water, refrigeration, lights, and comfort so that they can expand into areas where there is no grid or where they don't want to be carrying out fuel and diesel generators. Add in the NGOs that are working in microfinance, economic development, and sustainable agriculture, and the multiplier effect becomes significant. For us at TMI, we have imagined what would happen if we could price our fuel cell systems for the NGO market in such a way that we made a fair profit, but then what if we used our profits to put it back into the NGOs to help train them to use fuel cells and advance their own social mission and help the people in the villages? Is that not a smart marketing expense which sells more fuel cells? Thinking even bigger, what if we form partnerships and ventures with the same funders who are now sending those billions of dollars overseas? We could mix and match our private dollars with their social dollars. And for you attorneys, that's legal. Achieving a shared common objective would increase social returns on their dollars and increase our financial returns as volume drives our cost per system lower and lower. So far, this is a win-win scenario for TMI, for the funding agencies, for the foundations, and the NGOs. But how about the families who have to live on $300 a year? How can we make this pricey package and this rocket science affordable so that they can truly realize the benefits? Economists have a concept called marginal economics. Manufacturers call it second and third shift time. Computer service bureaus, when they were around, called it deferred batch. It's using the residual resources that are left over after the primary customers have been served. Any asset with a 24/7 availability can be structured to provide this surplus time. Fuel cells, which run 24/7, are ideal for this. Maybe you put 3, maybe you put 5, just a matter of how many to create the surplus time. What would they do? Well, it turns out that in a poor village, an awful lot of things can be done with surplus time. You could have the refrigerator to pump the water through the sand filters, refrigerators for food, perishable dairy products, or keeping vaccines for emergencies. We could, of course, recharge batteries for LED lanterns that could be part of an entrepreneur's business, cell phones, electric golf carts, which could haul hundreds of pounds of produce to the market, and even heat for central cooking and food processing. None of these that I described require real-time electricity or heat. They are all what we would call surplus. What about the fuel that fuel cells need? Well, it turns out that villages across the world already use digesters to recycle human and animal waste. They take these solids and use it as fertilizer. It's called night soil. And the gas that comes off is a biogas that can be converted into electricity. In India alone, there are 1 million villages without clean water or power. Our fuel cells run on biogas. In India and Africa, farmers grow jatropha. That is the plant that you see there. It's an oil-bearing plant that can grow, non-food oil-bearing plant that can grow almost anywhere. You can squeeze the oil using screw presses. You don't need power. Our fuel cells, we have tested on jatropha. As I close, or before I close, I want to point out to my local friends and colleagues here that nothing I've described in the last few minutes has to be invented or has to be developed. It all exists today. Right here, on the supply side, the technology, the workforce, the manufacturing plants, the appliance-like TMI fuel cell, all exist. On the demand side, NGOs, the persistent problems, the billions of dollars, the supply of biofuels, and even the medical teams and their ability to communicate over internet all exist here in this region. The only missing pieces are a bit of imagination and the will to act, and of course, the patient capital. And to all of the social capitalists that may be seeing this, why don't we figure out how to put a deal together and make this all happen? I'd like to close with a longer quote from J.K. Rowling again, from her address at the 2008 Harvard. Imagination is, and I'd like you to look at this picture above and look at the dark spots as I'm reading this. Imagination is the fount of all invention and innovation. In its most transformative and revelatory capacity, it is the power that enables us to empathize with humans whose experiences we have never shared. Unlike any other creature on this planet, humans can learn and understand without having experienced. They can think themselves into other people's minds, imagine themselves into other people's places. And many prefer not to exercise their imaginations at all. They choose to remain comfortably within the bounds of their own experience, never troubling to wonder how it would feel to have been born other than they are. They can refuse to hear screams or to peer inside cages. They can close their minds and hearts to any suffering that does not touch them personally. They can refuse to know. We do not need magic to transform the world. We all carry the power we need inside ourselves already. We have the power to imagine better. Thank you very much.